Okay, so hope everyone can see my screen. Good evening. Okay, so actually, whatever we have covered till yesterday, it's a Hadoop ecosystem. So it's a Hadoop feature. The big data, the base module is Hadoop, and with the base module with Hadoop, we can get, if we install Hadoop itself, can get the base model as well. So the base model that we have already declared, it's MapReduce should be there. There should be the HDFS, the file system should be there, and a particular cluster manager should be there. It should be earned, or any other kind of stuff should be there. By the base model, it should be earned. There is lots of other things as well, just like Mesos or anything. Today, we can use Kubernetes. So this kind of cluster manager, but Yarn is a default one which we can get in Hadoop. Okay. So Spark is a add-on component, just like there is Pig. There is another thing as well, just like Hive. So Spark is another add-on stuffs. So Spark can use the particular distributed file system from Hadoop. It can also use the particular, it should not have to use the MapReduce one because Spark is already having an inbuilt MapReduce thing. So it can only use the yarn and the lower base one module that is called distributed file system. So Spark can borrow the thing from Hadoop, and on top of that, Spark it is having its own functionality to do the thing by its own nature and all. Okay, and it's one of the why we are learning Spark. Okay, in most of the many of the projects, I cannot say most. Whatever Hadoop ecosystem we are using, we are not barely using Hadoop. The add-on services mostly of them we are using Spark. So Spark can be used by Scala as well as Python. If we are using the Python language over there, Spark interface is same. But the thing is, what kind of language I need to write the code on top of Spark. So it should be just like similar of Python. I need to install some libraries and all on top of Spark. And Spark should be installed maybe I can install it from my system as well. I'll let you know with the installation part quickly. Just to let you know that yesterday some of you asked the question what kind of data types it can support while coding and all. So it's totally dependent on the language, what language will be working. So that particular module you need to import. Okay. Now for the installation part, how to install Spark. I did not mention it over here because that thing should be hands-on maybe in next season. I'll uh, I'll bring couple of slides and I can bring another video for installation of Spark as well as how to do the hands-on on some IDE. Okay, the same kind of IDE what we have done over there in Python, that is PyCharm. So there is same kind of IDEs available. Like we can do the things IDEs or we can directly take some Linux server to do that thing. Okay. And another thing, if we are using any of the components, just like Azure Databricks, those are cloud component, there are the features available to install Spark. Okay. Just like EMR, AWS EMR clusters. So when you will be spinning up EMR, there should be default option as this is for big data purpose. So there should be default purpose. What are the components I need to install? Whether it should be Taze, whether it should be Hive. I can also install Spark by default over there. Okay. So if we want to program on top of that, no need to install that thing. Just we need to, that should be based on Linux server, of course. So we just have to log into AWS console or maybe somehow whatever the particular Linux server is there inside the EMR cluster, we can directly log in through PuTTY and we can open the Spark interface on top of that. Okay. So no need to install that if you are using the cloud providers or anything. But if you're not using cloud providers, we only try to install everything over there in our machine. Then first we need to install Hadoop. We cannot use Spark without Hadoop because from Hadoop, we are using two modules that I told you. The first module is the lowermost one, the distributed file system. which should not be there inside the Spark. So we are borrowing it from Hadoop ecosystem. So I can take that distributed file system from there. So that's why Hadoop needs to be installed. After that, Spark needs to be installed. It's also available in the web. It's open source uh, software as well. So you can download it from there. And just we need to check what, I mean, maybe, I mean, for the Spark, there is also some version. Spark 1.0 is the first version, then Spark 2 has been introduced. I'm assuming Spark 3 is now the current version over there. For Hadoop also, there is some version. So whatever version of Spark you are going to install, just check the corresponding or the correct interface for Hadoop as well. Okay, the version of Hadoop. So there are lots of options. Let me, I mean, show you. Okay, currently 3.32. So it, I mean, you can tell 3.x is the current version of Spark. So just you can put what should be the suitable version for Hadoop as well. Suitable version of Hadoop. There's lots of documentation available. You can open them and install it by your own. There is one more thing I want to show you. This is the most important. There is one page Spark by example. There we just need to put. Let me show you. I learned some of the architectural diagram from here as well. Yeah, Spark download option is there. So that kind of thing. Choose a Spark release, whatever Spark release you want to check it from here. Just like 3.x, you need to install Hadoop 2.7. Okay. So first of all, you need to install Hadoop 2.7. Then only you have to install. After that, you have to install Spark 3.x. Okay. After installation path, the class path and another thing we need to declare from the environmental variables and all. That is our latter part. But the main things we need to focus on that. And we need to install one IDE. Okay. So IDE should be connected with the Spark and we can code on top of that. Okay. So those are the different steps. I'll be telling you suitable link for, that is the suitable link. I'll be just pasting the same thing in the chat at the end of the session. But if you are quite eager, then you can quickly try to install it. It should take some time and I found some issue as well. But you need to troubleshoot this thing with your error messages and all. And this is not for all of your machines. Maybe some of you can get the error for some configuration or some more files needs to be imported because it's not a easy one that you are doing the big data processing at your own system. Maybe how many cores are been available, CPU cores are available over there, that should be segregated, or that particular program, whatever you will be learning in your machine, that should be splitted or distributed on top of that course and all. You can control this thing. So, but the thing is the particular installation and everything should be a bit tough over here. So I'll try to prepare a video as soon as possible, a recording, and I'll be sharing it with you. But it should not be possible by this season. By next session when it should be started, definitely for Hadoop, the hands-on part as well as that installation we can quickly cover up. Okay. Now, as per the theoretical purpose, let me go to the next slide. We can understand what are the things and how Spark should work in our daily life. Not daily life exactly. If we are having a solution using Spark for big data, then for that thing, what we are using. Okay. So first of all, what are the modules of Spark? Spark Core, Spark SQL, Streaming, MLib, and Graphics. Those are the all modules for Spark. But in this course, or mainly most of the project, we are only using the top two. This is for streaming purpose, the video streaming and all who are using this kind of big data technology or learning Spark. So they're using this kind of streaming, MLib, graphics. So those kind of stuffs are there. But simple data operation and all, we can use only top two. So those are the different coding language. We can choose either of the one, either Python, Java, Scala, R. Python and Scala are almost same, even R as well. So just some syntactical changes are there for R and sorry, for Scala and Python. We can choose any of the one. If we are using Python on top of Spark, that is called PySpark. Okay, it's not a different one. And Scala is the native language, and it should be. If we are running the code on top of Scala, then it should be a bit faster because particular Spark is written by Scala itself. Inside, the code inside Spark is in Scala. So if we write the code in Scala, then the interface should be fast. A bit faster should be there, whatever we are writing in Python. Okay. So, over here, we can go through with the example on top of Scala only. Let me show you one by one. Okay. So this is the architectural diagram, how the code should run. Okay. So when we are running the code, we need to declare a Spark context. A driver program should be there, which should be creating the Spark context. The first one, Spark context will connect with cluster manager. Cluster manager might be Yarn, what we have checked it yesterday. Yarn is yet another, resource negotiator. So whatever resource I need to assign, whatever worker nodes should be there, we can assign this thing by Yarn. Okay. So first of all, we need to declare one Spark context, then that should contact with Yarn and assign the worker nodes. Okay. In the worker nodes, task node should be there, and we need to just give the particular memory sizes of each of the task node or executor node. Okay, over there. I'll be just quickly show you an example while we'll be running the job. Then that should be understandable. Okay. Okay. Now, from the data perspective, that thing, the architecture, just you can quickly remember. I can come into the point quickly. Various time, especially Spark context. While running each of the code or while declaring each of the data frame or RDDs, we need to declare the Spark context. This is the entry point of the programming. We need to declare one Spark context. Then on top of Spark context, we can create the data frames. Just like Python for pandas, we have created lots of data frames over there. Over here, we need to uh, first call a Spark context. On top of that, we can create RDD and data frames as well. Okay, now what is RDD? RDD is called Resilient Distributed Data Set. So just same like data frame, it's one kind of data frame we can say, and it's the basic unit of data frame. So when Spark 1.0 was introduced, RDD was the only steps. It's the only data structure we can say over here. Data structure means the collection of the data. Just like list, tuples, the same kind of thing we can convert into one of the data kind of stuffs. Okay, so RDD has the capability. RDD is one of the API to convert the thing, and it's the basic one. So it's a fundamental data structure of the Spark that I told already. Now, how to work on top of RDD and what are the extra features? How we are doing the map and reduce. That I told yesterday, map and reduce, both of the thing is distributed in nature over entire clusters. Okay. So how the program is faster? We are using those kind of transformation. That's why I mean, mapping transformation, flat map transformation, those are the transformation available. What we can work on top of RDD. That's why the thing is distributed in nature. Distributed means whatever clusters are available, that can be the particular calculation or computing power should be distributed over there. Okay. Now let me go through. Yeah, Spark context I just mentioned. Spark context is an important thing. Each of the programming, we just need to start with Spark context. Created by the driver program, obviously, and it's responsible for making RDD. Okay. Okay, Spark Shell is another thing. I'll be coming to this thing later. What is Spark Shell and the endpoint? Then I can quickly discuss that point as well. Okay. Now, if we are on the console or if we are opening any Linux output is over there to open that thing. So, just like creating statement of RDD, we can create in this way. You can see this is a list. Actually, the code is been written in Python over there. This is a PySpark code. There is a slight different. I'll be coming with one of the Scala script as well. After that, then you can change the thing. I mean, get the change. What are the difference between Scala and Python? There is very minimal change. First of all, for Scala, suppose we are declaring a variable. Okay, in Python, we can directly type the variable name. Suppose var equal, I can assign some value. Okay, but over there in Scala, while declaring a variable, there must be having a keyword, just like var, then the variable name, then assign the value. Okay, so this kind of minimal syntax is there, syntax change is there. So you can choose either of the language for doing the program, and based on that, the particular library needs to be installed, and you can work over there. Okay, so just like over here, the first I tried to create some RDD on top of list. Okay, so I need to import the particular libraries that I told you earlier. So over here RDD, I'm creating RDD that the name is itself RDD. So I mean RDD equal sign is there. This is the particular classes Spark. I'm creating a Spark context dot parallelize 1, 2, 3, 4. It's a list. If I do that, RDD will be created. RDD is a basic data structure. I mean, on top of RDD, we can do lots of operations, just like join, flat, I mean, mapping things and all, everything we can do on top of RDD. The similar kind of stuff, I mean, we can read from a text file as well. The text file might be located in the HDFS system that I told you, or it might be located in any of the, I mean, if we are working in AWS, then we can store it in S3 bucket. Okay. If we are using in Azure, the same thing, we can get it from blob storage. So similar kind of stuff should be there. Okay. If it is stored in S3 bucket, we have to put S3n slash, I mean, then the drive path, the path should be there. What file I want to read. And from that file, it will be creating the RDD. So hopefully you can remember whatever we have learned in while running Python data frame or while creating a Python data frame. We are using pandas dot data frame and we are pointing to a particular file path. So the similar kind of stuffs can be done over here as well. Okay, but everything over here, what we are doing, it should be distributed in nature. So that the compute process should be splitted between across the particular clusters and the thing should be very much faster. Okay, so I put some code snippets as well. This is Scala code, obviously, and you can see I'm just declaring just like val data sequence equal. This is a tuple set. Over there, I'm passing 3 rows. Java 20,000, Python 1 lakhs, Scala 3,000, just like this way. Then I'm just putting, I'm declaring one RDD, and RDD needs to be declared in this way. Spark context parallelize and passing this data sequence over here. The RDD should be created. Okay. How to print the RDD? I'll be coming to this thing later. And this is one of the thing. How to create from the text file itself. Okay, the same thing just I mentioned there earlier. That was a Java code. It is itself a Scala code. The difference is only this particular variable val. Okay, val, I'm assigning a constant value that is called val. If it's a variable in nature, so that value can be changed, then it should be var. So this is totally basics for Scala. Scala language, it's a different scripting language, especially object oriented, just same like Python. Okay, the syntactical difference is there. I learned Scala first, then Python. That's why I have both of them. I mean, idea of both of them. What are the changes and all? So those are the minimal changes. Okay. Now inside the RDD, that is the part what we have covered. How to create an RDD. RDD is a basic data structure to do the data related operation in RDD in big. I mean, you can say in Spark, the basic one. But how to transform the data or how to uh, do the manipulation for the large programming and all, that is been covered in transformation and action section. There is two different part. One is called transformation, one is called action on top of RDD. It is a good interview questions as well. What is the difference between transformation and action? So transformation, if we are doing any transformation on top of RDD, it should be creating another new data set from an existing one. And action, it will not create a new data set. Rather, from the existing data set, it will from the action item, whatever action we are doing, a particular value should be returned, which should be operated on top of this RDD. Okay, and the value should be returned to the driver program itself, the Spark context. On top of the value, we can work further, but it will not create another RDD. Okay, for the transformation, it will be creating another RDD. Now I have few commands for transformation and action. Yes. So those are the thing: map, flat map, filter, distinct, sample. So those are transforming keyword only, and those are distributed in nature, of course. So how much clusters are available over there? If we operate on, on top of RDD, I'm just doing map function or map operating on map, then the operation should be distributed across the entire clusters. Okay. So that's why, RDD is working as a distributed component or distributed data structure over here. It should be working as a big data component. This is the difference, and this is been a uh, the same kind of thing. You can see whatever we are doing in the Python over there and over here in RDD. Not exactly RDD. The top API of the RDD, the improved level of RDD. It's called data frame. That we already covered, just like Python pandas. Okay, but while learning the Python, we did not have the distribute. We are not distributing the code among the clusters. But RDD or the higher version of RDD, that is called data frame or data set. I'll be coming to data frame and data set in the later slides. But all the stuffs are distributed in nature. Okay, so that is the main fundamental things I want to convey. So those are the operation we are doing for transformation. Just like this is one of the mapping function. How map things should be work. So I'm declaring another data frame over here. Okay, it's a transformation, so I can create another data frame. The existing data frame is this one. So it's a square of RDD equal RDD dot map. I'm using a lambda function. Okay, so in the lambda function, the input is X, and that should be one-to-one mapped with X cross X. So whatever X data I'm passing as input parameter, at the output I can get X cross X. So this is lambda function. If you have some idea on lambda function, then that is very much easy. So whatever RDD is been created over there, SQRDD, the element should be doubled. Squared. Sorry, it should be squared. Whatever there in the existing X, it should be squared. But the entire calculation should be distributed in nature, distributed across the clusters. Okay. So this is a simple code snippets I just put to you. So there are various action items as well. The action will not create a particular data frame or RDDs over here. Rather, it can do some operation that is called collect, count, count by value, take, even the reduce as well. Map reduce. Reduce is not a transformation. Rather, we can say reduce is an action. So it will not create a separate RDD. Rather, it will pass some value to the diver program itself. By using this value, we can print the value itself or we can use that value in the further programming language. Okay. I do not have any code here, just like this one. RDD collect. So how to print RDD? There's an option. Whatever RDD I'm creating earlier, the same thing I can print in this way. RDD.collect for each print line. Okay. So this is not create a new data set. Collect is an action item. So I'm collecting the RDD and passing it to Spark context, the diver program. And for each line, I'm printing it over there in the screen. Okay, this is printing of the thing. Just like the same, we can print data frame over there in Java. Sorry, it's in Python. The same thing. We can print RDD over here in this manner. But the collect operation is a action item over here. It's not creating a new RDD. Okay. So we just covered what is the transformation and what is the actions we can do on top of RDD. So I think those are the basic thing for RDD as of now. But definitely it should be good if we have the hands-on exercise. I am assuming so. So I'm trying to, get the particular access or particular hands-on thing or hands-on setup on my machine, or I'll try Lohit or other team if they can help me with some of the cloud vendors. Anything, I'll be trying it as soon as possible. Maybe next season I can, when the thing should be started, I can ping once more so that you can quickly join for 1 or 2 days to get accustomed how we can do the thing. Okay. Okay. The next topic is data frame or data set. So it's just like the upper stuffs. So in Spark 1.x, we are using RDD. This is the basic data structure that was been introduced that time. So when Spark 2.x has been introduced, those are the extra features. Rather, we can say this is the upper level API of data structures. Okay, it's very much similar, just like Python data frame itself or Pandas data frame. Okay, a lots of extra privileges we are having with it. What are those? I can quickly show you. And just like the first point, it extends RDD to data frame. Even we can convert RDD to data frame to have some data frame privileges. There are some extra operations or just like the same kind of operation what we are having for pandas, the same kind of operation should be there in data frames as well. Pandas data frames over there and pandas, over here, data frame and data sets, those kind of things are having those kind of privileges. We can easily do the joining part, we can merge the thing, we can do the grouping part, the aggregation, anything we can do quickly on top of data frame. We can do the filtering things and all over there. But those are distributed in nature, whatever we are doing it in Spark. Okay. And there is another module called Spark SQL, what we can do on top of data frame or data set. And we can have the same kind of SQL interface. So whatever we are learning at the SQL side, just like select start from table, we can do same kind of things in Spark SQL. That should be operated on top of data frame only. So this is the extra features that we can get. Okay. We can have the interface of SQL. No need to use the data frame operation or RDD operation or actions over there. Directly use the SQL and uh, do the data analytics stuffs. But that should be distributed in nature as well. The SQL will be much more faster. So this is the examples of code snippets. Okay. First of all, is there any doubt in your mind? the particular topic is a bit higher, or if you are starting with the basic data engineer, you just learn Python and SQL. So Hadoop, it's not only for the coding purpose, the architectural purpose as well. You need to learn the thing. Maybe it should be a bit tough or not sure. It is good for crash course, but I am trying to show you the basic one. As much I mean, whether you have the understanding how it is working and all. Hopefully it is understandable, but if it is not, then you can quickly tell me. Is there any doubt or any confusion you want to, I mean, convey the thing with more easy manner or anything?
Yeah, hello. Actually, it's not a doubt. Actually, I want to clarify. I heard like PySpark. So, what is the difference between like Spark and PySpark?
Okay, Spark is a total tool or add-on tool. We can say what should work on top of Hadoop. Okay, so it's the same as PySpark, but PySpark, the Spark, whatever we are working, I mean, if we are changing the language, we are working on top of Python. I mean, the language is Python on top of Spark. Okay, then it is called PySpark. No difference. Spark is a tool. A particular tool is this. Okay, a big data tool, a big data component. And PySpark, if I using the Python language to code on top of Spark, then it is called PySpark. The technology is called PySpark. Okay, no other difference is there. Let me show you. Okay, let me print this thing. Even this is good for interview as well. Over there, you can learn lots of stuffs. Okay, PySpark. You can see Python interface for Spark. Similar, there is Sparkly R interface for Spark. The tool is Spark. Okay. We can, I mean, code on by Scala and Java as well. The name is not changing. So the overall tool is called Spark. The particular diagram that I showed to you. If I'm changing the coding language to for our data manipulation, the particular technology is being changed. In your CV, you can just put PySpark over there. If you're using Python, okay. Similarly, if you know entire stuffs, you have knowledge for R or Java or Scala, you can have a bit coding over there. You can just put Spark, or you can tell them you have worked Python on top of Spark, Scala. You have also learned Scala as well. You can work on top of, I mean, by Scala, you can also code on top of Spark. Okay. So that's the difference for PySpark and Spark. Hopefully that is understandable.
Yeah, yeah. And one more thing, can we use Java, Scala, Python in for the same purpose,
No, I mean,
like a
better,
project?
I mean, for the coding structure, we need to use only one at a time. If we're developing one application, the ideal scenario, we should not have to merge them. Okay. So just pick one of the thing. Specifically, as of now, we can work in Scala or Python. Those are the popular one as of now. Java also, it's in market available for the Spark as well. But as per my experience, I checked that Scala and Python is highly available. So if you are running a code, s- I mean for anyone, you have started it for Scala, then I'll suggest not to introduce Java over there. You can definitely use, but face some issues and all. Okay, so you should not use both of them at a single program or single code. Okay, just use only one at a time.
Okay, okay, sir. Thank you. Thank you.
Okay. So I mean, we are in data frame. So data frame is just like upper API. So if we know data frame, no need to go to RDD, but specific operation is there. Basic level operation, we can go ahead with RDD. We can follow only RDD. We have to follow RDD. There is no such way in data frame. Some of the solution we can see, it's suitable for RDD only. it is feasible in data frame, that should be tough. There is also such kind of scenarios we have faced in history. But how to create the data frame? So here is some example. I'm creating some sequence over here. Then I'm declaring the columns. Columns is the particular header, we can say over here. So how to create the data frame? It's a data frame, not RDD. So I'm declaring a data frame equal spark dot create data frame. I'm passing the parameter data. This is the data, and the schema equal columns. These columns. Okay. So this is particular data frame syntax. So by creating the data frame, we can print the data frame as well. df dot show. The methods is available show. Okay. Inside the show parameter, just like in pandas data frame, we can print just like df dot head, head one, head two. That should line should be printed in this manner. By default, it should be 5. I'm passing head 2, then top 2 lines should be printed over there. Over there, we can print in this manner. I mean, df dot show, inside show, we can pass 1, 2, 3, how many lines I want to print. That should be printed over there. Yeah, so if we just print df dot show, this is the way we can show the data frame. Whatever we are declaring over here, the sequence, the same thing is in data frame format now. It's similar kind of Python data frame. No more difference, but this is distributed in nature. Whatever what we are doing over there, what code we are writing, while doing this thing in backend, it's distributed in nature. Okay, so the performance will be much more faster because we are not going to work over there for 5 or 10 rows. For the industrial purpose, there should be million of the rows, million of the records. So the performance should be very much high over here. Even we can see in the document, it's 100 times faster than the normal coding strategy. Okay. Okay. Now I'm just introducing what is Spark SQL or how to introduce that. Spark SQL means I told you earlier that we can just type normal select query on top of data frame. So on top, I mean, there is the existing data frame that is called DF. I'm using create or replace tame view. That is the method. So that data frame I'm converting a particular table name. I mean, a tabular structure. I'm just pushing that data frame over there. Okay. Now by using spark.sql, I can read the data from here, or I can do any kind of SQL query on top of this particular table. I have to put the SQL query over here only. So whatever we have learned in SQL, various coding and all the SQL language stuffs can use over here itself. Okay. So it's a different data frame as well. df2 equals spark.sql and a particular tabular structure. Okay, moving to the next slide. Okay, we can just there are some different examples as well. We can read from JSON or any other SQL file. I mean, text file, just like Spark read.csv. If it is CSV file, then put the file particular file drive's name. Okay, the same kind of Hive context. It's from Hive table. If I just connect Hive database, we can just type in this way Hive context.sql, then particular schema and table name we can read by select query. This is also possible. Okay, those are the different steps how to create the data frames. Now, what are the different operations on data frames that I show earlier? That's data frame dot show. It should print the result. For selecting particular columns value, we can choose in this way. Data frame dot select. Inside that, we can put within inverted comma, we can put the column names over there. It should be printing on that columns only. Just like slicing operation on Python data frames. A bit syntactical modification you can see over there. Filter. We can use filter in this way. Okay. Group by the aggregation functions. Okay. I'm converting the result to RDD. Then I'm doing the map operation. I'm converting it's the result is in data frame, but map is available in RDD, not in data frame. So I'm converting to RDD first. It's a transformation on top of data frame. I can do this thing in two steps. Just like I can assign this thing till RDD in a variable that should be a data frame of, I mean, that should be RDD, of course. Then on top of RDD, I'm doing the map operation. Map operation is very much useful. So I told you some examples or some solution is not possible from data frame itself. Then that time we need to use this kind of map function, dot map operator over there. Okay. So those are all the operation. There are lots of operation. I just tried to pull some of them. The important one and the things. Now, when our code is ready, the code snippet, I mean, we just I mean, go ahead with the data frames and all. But if we have the big codes over there, if our code is ready, then we can run the code in this manner. There we need to declare the driver memory, the executor memory. Okay. What should be the executor code? What should the code number? So we can go ahead with some trial and error method to submit this thing. Just like this is a submission of a particular job. Okay, so whatever code we have written, that should be transformed in a job, and that job should be run from the CMD prompt or anywhere. There we can declare this kind of memory, executor memory. So we can have a trial and error, what are running faster or I mean what things are running slow. So based on that, we can determine what should be the driver memory for this code to run this application arguments. Then we can quickly determine and pass this value over here. Okay. So this is very important over here. So that's why you can controlling the memory related parameter. On top of this driver memory and executor memory or number of executor codes, the things are distributed in nature. Or while running the code, the thing will be distributed there. Okay. Okay. With Spark, we can receive some UI user interface. The same thing that I want to, I mean, try to tell you Apache Ambari. So the same thing, just like there is some user interface for Spark as well. So whatever jobs we are triggering from there, or whatever jobs are running or anything, what are the executors, those are live there. So those kind of things we can check it from Spark UI user interface. Just like while we are running the job, there should be an app ID will be generated, and when they have started the completion of the particular submission and all. So those kind of control we can get from Spark UI. That should be also we if we just using a cloud provider, just like if we are launching EMR, then Spark UI IP they should be providing. Okay, by checking the IP in our Windows Explorer, we can open the UI quickly. No hard and fast rule. The IP is already been provided with the service provider, and just we need to type the IP in our address bar and we can go to the Spark UI itself. Okay, so this is the way we can check in UI side what are the running jobs. If there is any code or node failure is there or anything, we can check it from the UI side. Yeah, those are the all and basic stuffs I tried to understand. I mean, give you the knowledge as a overall basics. Uh, I'll be quickly trying to install that I told already. Particular so to show you the hands-on exercise or anything. And okay, I'll be contacting the admin as well if we have this kind of I mean the environment from the cloud provider so that we can install EMR or we can install the particular Hive or everything on top of EMR so that we can have some more classes on top of that one. If there is anything, that's fine. Otherwise, I can install ID in my system and I'll show you the same over here. Okay. So that's all for today's session, the basic one. Is there any doubt from any one of you? No doubts? Okay, fine. So tomorrow should be the last class actually. So if there is any doubt or any more questions, you can ask me. But it should be very much, I mean, we can just quickly cover the one exercise that I have provided you earlier on top of data frames. Or I'll be checking if I am missing any important topics in SQL or Python or any other stuffs. Then I'll try to cover up, and I'll be having a quick introduction. I mean, interactions with you as well. Maybe your feedback or anything we can quickly discuss. It should be a small session, maybe within half an hour it should be completed. But it should be the last session for this season for tomorrow. Okay. Okay, then let's connect tomorrow. Thanks. Thanks everyone. Bye bye.